Dear students, can you tell me what is this that you can see in the picture? Wait for the next 5 minutes and you will get to know. Well, scientists have been trying to convert heat into successful work, good work, right? Since time immemorial. We don't even know when did they start. Our memory does not permit us. But in today's world, if you see, we have been able to convert heat into work very successfully. And the examples of our success are IC engines, which we use in our automobile, jet engines, which we use in our aircrafts, and the rocket propulsion. Through all these technologies, we have been successfully converting heat energy, which is generated by combustion of the fuel, into successful work. That is driving of the car or the aeroplane or the rocket. But if you want to understand these engines properly and if you want to design it, what are the basic sciences involved in this? So the basic sciences involved in any propulsion system are the six. Laws of motion, which is basically a part of engineering mechanics, thermodynamics, which we are talking about in today's video, principles and theories of aerodynamics. And you heard me right, aerodynamics is a very important part when we are designing the propulsive systems. Mechanical sciences. Well, it is not enough just to design the propulsive systems, isn't it? We also need to manufacture them. And for that, we need to understand manufacturing engineering, production engineering, theory of machines, heat transfer, machine design, right? So this all comes under mechanical sciences. Then material sciences is a very important part because we use cutting edge, the advanced of the most advanced material in this propulsive device. Why? Because these devices that you saw in this picture, right, they have to withstand very high temperature and very high forces. And that is why we need the best of the best materials. And finally, control theory, which helps us to control these devices. What is the use if we design a device which we can't control? Now, we are not going to concentrate on everything, but we are going to concentrate on the thermodynamics part. So what exactly is thermodynamics? If I want to explain you thermodynamics in simple one sentence, it is the study of energy, heat, and work, and how energy is stored and it is converted, right, using this different systems, right, into useful work, and vice versa, right? Vice versa, because we also convert work into energy, like in our refrigerator, air conditioning systems, right? So both the way it is required. Now let us go back to our first question. What is this? Well, this is Hero's engine. This is the first engine that has been registered in the human history. It was developed by an engineer named Hero, right? In the first century AD. First century AD means 2000 years back, right? And it converts thermal energy into rotational kinetic energy. So let us see how does it work. So you can see there is fire, right? The wood is being burned to generate fire. And there is water inside this chamber, right? Because of the fire, the heat converts the water into steam, and the steam flows up through these pipes and it fills up this spherical vessel. Now, slowly the pressure starts rising. Now, as the pressure starts rising, right, the steam starts coming out through these nozzles. Now, as it comes out through these nozzles, a thrust is being produced, right, which we will learn subsequently later on, right? And as a result, what happens is that the spherical ball, it starts rotating. Now, we can actually, right, connect this spherical ball with a shaft and we can use this for meaningful work. So Hero, 2000 years back, right, he was able to convert heat energy into successful work. So today we understood what is thermodynamics. It is study of energy, heat, and work, how energy is stored, and how it can be converted in systems. This is the basic example how heat energy is converted into work, right? And we have seen what are the basic sciences which are involved in propulsion designing and understanding a propulsive design, propulsive device, right? And these are some of the examples of our success, how scientists have been able to convert, right, heat into work successfully.